In this video, we'll start looking at SD+. SD+ is an extension on SD. And the whole idea here is to make your derivations shorter and simpler. So SD just has one intro rule and one elimination rule per connective. So it's got this nice symmetry to it. SD Plus is more of a grab bag of rules, but they're very intuitive, a lot of them. Very widely used in deductive reasoning. It gets back more to sort of older natural deduction systems where instead of trying to do this, sort of simple symmetric thing like SD does, they would just sort of, look at the way that people did prose proofs and things like that, look at the inferences that they were making, and then just kind of throw all of those rules in formal versions. Um, So nothing in SD Plus is actually new. Everything in this, all it is it's actually, they're just shortcuts and they correspond to inferences that are derivable in SD. So instead of having to go through a long sort of, little chunk of derivation, which is what you'd have to do in SD Plus, you just have a rule that allows you to do this in one step. The main thing that means then is that the rules in SD are all optional, right? If you're ignoring a rule in SD, um, like let's say that you decide that you don't like or elimination and you're just not going to use it, there are derivations that you just won't be able to complete because of this. SD plus is different. If you ignore a rule of SD plus, then there are derivations that will be longer, but you're still going to be able to complete them because you've got everything in SD available. And SD plus doesn't allow you to derive anything that you can't derive in SD. It just does it in a more, more efficient, shorter sort of way. So here's an example. Here you have this is an inference that you can make in SD. So if you have a conditional, if P then Q, remember these are metavariables, they can be any sentences. And then you've got the negation of the consequent of the conditional. Then you can derive the negation of the antecedent. And you do it just by assuming, you assume the antecedent for negation introduction. You can derive contradiction here, this by conditional elimination, this by reiteration, and so then you get the antecedent. In SD plus, you can do this in one step. You just have the conditional, the negation of the consequent, and then you can just immediately infer the negation of the antecedent. And then you just cite it with the line numbers that these first two are on, and MT, which stands for modus tollens, which is the traditional Latin name for this particular inference. Bear in mind, we talked about this way back in an earlier video about the fallacy of denying the antecedent. Don't confuse modus tollens with denying the antecedent. So it's the negation of the consequent. From the negation of the consequent, you can infer the negation of the antecedent. From the conditional and the negation of the antecedent, you still can't infer anything at all. Modus tollens corresponds to arguments like if John is in Toronto, he's in Canada. John is not in Canada, therefore he's not in Toronto. And that's something that's obviously valid. Okay, another inference rule that you have in SD plus is called hypothetical syllogism. So in SD, you can have part of a derivation that looks like this. If you have if P then Q and if Q then R, then you set up a subderivation for conditional introduction. You go start with P, you infer Q by conditional elimination, infer R then by conditional elimination, and then you can get if P then R. And again, whoops, SD plus, you get to do this in one step, and you cite it HS for hypothetical syllogism. Now, disjunctive syllogism, in SD, you get this big long derivation. The basic idea behind it is this. If you have a disjunction, you know that one of the disjuncts is false. Well, I mean, the disjunction says that either P or Q has to be true. P's not true. Well, then clearly Q has to be true. So in SD, this is how you would go through and establish that Q has to be true. And because disjunction is symmetric, it also applies to the other disjunct. So if you've got the disjunction and then you know that Q is false, you can infer that P is true. SD plus allows you to do this in one step. So from P or Q and not P, you can infer Q. From P or Q and not Q, you can infer P. And they're both cited then DS for disjunctive syllogism. This actually is an incredibly useful rule. Because of the fact that, I mean, this one step thing, what you're replacing is this, which is just way too long to be inserting into derivations. This is really, really valuable to be able to do this in one step. Now here, remember not to confuse this with this disjunctive fallacy from P or Q and P inferring not Q. What makes this a fallacy? Well, look at this argument, right? You can put sprinkles or chocolate syrup on your ice cream. You put sprinkles on it, therefore you won't put chocolate syrup on it. This is not deductively valid. And it illustrates what's wrong with this inference, right? The problem with this inference is that it assumes that the OR is exclusive, which in SL it isn't. So that's the problem with this inference, and that's why you can't make this with the inclusive OR that's used in SL and SD. So these are the three new inference rules of SD plus. And remember that you're not required to use any of these. You can still continue just using the rules of SD. These are, however, very useful in simplifying your derivations. I mean, even though like you're not technically required to use DS, I would really strongly recommend you learn how to use it because it simplifies things so much. So they're very, very useful, very valuable, but of course, they're not necessary. Anything that you can prove with SD plus, you can also prove with SD. It just takes a little longer. So we'll work through an example of the inference rules of SD. We'll show that this set entails this sentence. So I've already laid out the members of the set as assumptions in this derivation. Put the set down or the sentence down to the bottom as our goal sentence. Now F doesn't occur anywhere as a subcomponent of any of these. So the only way that we're going to be able to get this then is by deriving a contradiction and then using the principle of explosion. So we're going to want to get this D and not D. So we're going to set that as a goal sentence. We're not, however, going to use negation elimination. I'm going to put that down as a goal sentence here, and then I'll show you a neat little trick that you can use in SD plus and to make use of the principle of explosion instead of using the negation rules. All right, so we'll work top down for a bit because the point of this is to illustrate the inference rules. So from not E and B implies not E, given those, we can use modus tollens, and we can infer not B by 3 and 4 MT. We also have, here we have this, and here we have this, and HS, hypothetical syllogism, lets us just eliminate that middle term C there. So we can infer that this implies this. Better make that a little bigger. By 1 and 2 HS. And then we can get the antecedent of this from line 5 by disjunction introduction. And then these two here will let us get D and not D by conditional elimination. So that's 6 and 7. Conditional elimination. Okay, now we have our contradiction. We've got D and not D in the main derivation. So then what we can do is this. We pull both of these out using conditional elimination, like so. 8 and E. Copy that down to here. Then we're going to, from 9, we're going to get D or F with or introduction. And then we use disjunctive syllogism. So we've got D or F by or introduction, and not D means that the D case must be false, which means that we have to conclude that the F must be true. So disjunctive syllogism allows us to infer F. And so there, we've managed to get F out of that without using any of the negation subderivation rules.